Hi, Gil from Testing Gil here, and today I want to talk about how we read code and what we consider simple code. Did you ever think why it's called code? Whatever we're building becomes zeros and ones. The code part is an abstraction from the text that we write into those zeros and ones that run. Our code's abstract binary. Sometimes it's from the developer side too. The problem is that today it takes less than 3 minutes to find out it was asked like 3 weeks ago. There are a lot of principles of clean code, which I teach by the way, check out the links below. And a lot of them relate to simple code, code that we consider simple. Simple code is easy to understand, right? Here's a bit of code. Do you consider this code simple? When I ask this question in my classes, people first identify the names and then understand how it works. It calculates factorials, and it does it by recursion. And then they start to think. It's only a couple of lines of code. It looks simple enough, but then they start thinking about the recursion. And recursion is not simple, even if it looks simple. What makes it complex? Well, one thing is that the code runs differently than how it looks. Think about it. When we read code, it's top to bottom. And we start playing a movie in our brains. First, the first line happens, and then the second one, and then the next one, and then the next one. But with recursion, it doesn't work like that. We understand that, we know that, and then we identify this as a complex thing. Complexity comes with a cost. More time, more bugs, more risks, more debugging, and more testing. You know what other code behaves like that? Concurrent code. When threads are running through this code in different sequences, it is not a line-by-line story. Again, our experience tells us this is risky business, and we identify this as complex code. Concurrency, thread safety, synchronization, all these are very complex. So, no, I'm not suggesting that we write everything like a big God mode function that does everything line by line. Our brains don't deal with these things too well either. But if you're trying to build something that solves a complex problem, simplify the design. When you're coding it, simplify the code. And where you're reviewing code like that, simplify it further. Smart code may work, maybe. But it comes with a lot of maintenance headaches. It introduces risks, it introduces bugs, costs us a lot of time in debugging and just moving slowly, and as a rule, impacts time to market. And not in a good way. Simple is good. We should have more of that. That's it for today. Thanks for watching. If you like this video, like, subscribe, and check out other videos on this channel. And in the comments, tell me about how you saved yourself loads of work just by going simple. I love simple stories. Until next time, bye-bye.